All right. Hi, everyone. My name's Ryan. I am an Elixir developer working at CultureAmp. Well, I kind of do that, but I also do Ruby, but I also am a developer, I like to say. I teach developers how to develop themselves into developers. So one way I've been doing that recently is by helping people work through the toy robot exercise. And who here has done the toy robot exercise? A few of you. Cool. So you all know what it's about. It's pretty cool. It's usually used as a job interview coding test. So what you end up having is like, you'll go and apply at your favorite coding company, and they'll send you a coding test that's in like a zip file. And then you open this and then there's a README and you're like, okay, I'm just gonna read through the README, and you're like, oh, this is page 1 of like 94 things. And where the hell do I start? This toy robot exercise, it comes in like this, I don't know, 250 to 300 word description. It feels like a major undertaking. I'm just going to walk you through what's involved in this talk. First of all, we start out with nothing. You know, there's just the void. And then we have the grid, or what we call the table, which is a 5 by 5 grid of squares. And then onto that table, we place our little robot friend. This little robot starts in a position called the origin. It's called the origin in the instructions, and this is 0, 0 on the grid. Sometimes it gets referred to as the southwest corner, which kind of makes it easier in the future for future instructions. We'll get to that in a second. But what I wanted to say here is that lots of people will use the coordinate system of like 0, the first 0 meaning north here, and the second 0 meaning east. I like to reverse the two here, just to match my brain up with like how a Cartesian plot would work. So we have the X going horizontally, and we have the Y going vertically. So the digit on the left indicates left to right, and the digit on the right indicates up and down. Fortunately, in this case, we only have positive digits to care about. I could call them X and Y in this case, but instead of doing that, I'm just going to refer to them as east and north. So far, so good? All right. So we have our grid, and we have on that grid, we have a robot. But in order to put the robot there first, we have to give it a command. And one of those commands is a place command. When we say place the robot, we say place it at this particular east coordinate, this particular north coordinate, and it has to be facing a certain direction. In this case, I've chosen east, but that could be north, south, or west as well. So when I have placed that robot, it ends up here on the grid. If I place the robot at 0, 0 north, it actually ends up here, as you might expect. Notice that it's facing up, or north in this case. Other commands that the toy robot can do, that it can move. Well, Keynote animations, aren't they amazing? It can also turn right and move. So first of all, it can turn right and then move. That's 2 separate commands it does. Not only can it turn right, just like Zoolander, but unlike Zoolander, it can also turn left and move, as you can see here. And the final command that I'd like to cover is report, which has to report back the robot's current position in terms of the east and north coordinates, and also the direction that it's facing. So we've got move, left, right, and report. These are the commands that our robot has to follow. Thankfully, in Elixir, it's really simple to build something like this. What you might do is you build this module called toy robot robot. It's a struct, so it has a north coordinate and an east coordinate, also a facing direction. You build out some functions like move, turn left, turn right, and it means that you can end up writing code that looks like this, where you just build up a robot and then just pipe a bunch of functions to it, and you end up with the robot, you know, facing a certain direction and at a particular east and north coordinate. Everything is awesome at this particular point. And because you're a really good developer and you write doc tests, you can run mixed tests and you can have everything really happy. By this point where you're thinking, you know, you're 5 minutes into this coding test and you're like, that's not really hard, I must be a professional. You must be thinking, well, I'm a god at this. I'm excellent at Elixir. And you think, well, you know, that creeping doubt in your mind says, well, maybe I'm not a god. I'm going to go back through these instructions. Take a closer look. And you look through the instructions and you skip past the first sentence because you've now mastered that. The second sentence says, any movement that would result in the robot falling from the table is prevented. And you're like, oh, hold on. All I've got in my code base here is a robot. I don't have a table. So now you actually end up seeing the whole picture, which is like, yeah, so you end up, okay, you go back to the drawing board and you start by building up this table module, which is basically the same thing. It's a struct, it has a north boundary and east boundary, and we can determine if it's if the robot is in a valid position by passing in a table and the north and east coordinates of the robot, and then with some basic if statements, we can say like, if the north coordinate is a positive value and it's underneath the north boundary, that's good, and same for east boundary checking too. In order to join the robot and the table together, you build this thing called a simulation, because that's the kind of thing, excuse me, that's the kind of thing they're looking to, you know, that's the instructions say it's supposed to be a simulation. So to join these two things together, you have a simulation module, which has a table and a robot. And then you can write code like this. You can say that there's a table and that we're going to place onto this table within the simulation a robot that's at north 0, east 0, facing north. And you get a simulation object from that. From there, then you can do simulation move to then move the robot within that simulation. And just like before, you could chain functions on top of this as well. So you could say a simulation move again to move the robot one more space, or turn left or turn right, and so on and so forth. The main thing about having a simulation like this is that you can join those table and the robot structs together, and you can do that checking with the valid position of the robot. So if the robot, in this case, happens to be at the top boundary, right? If it tries to move again, it's going to fall off the end of that table. So now you can prevent that by having this simulation module instead. As you're a good developer, you've been writing more doc tests and now actual XUnit tests too. So you have 10 doc tests and 8 tests and 0 failures. This is the first time you've ever written code before in Elixir. It's amazing. It all works because that's what Elixir does. So what the robot should do is if it reaches a boundary, in this case it's the east boundary, it shouldn't move past that boundary. In fact, it should be denied. That should never ever happen. But instead what it should do is it should just kind of wiggle there. Good, that animation does work. So the robot doesn't move past the boundary. It can't escape from the cage it's been put in, which is very good. All right, so that's the second paragraph. It's the robot can't move past the boundary in the table. The third paragraph says the application reads a file using a name passed in the command line. All right, well, we don't have a command line for this. We just have some Elixir code we're running kind of like in IEX or just mixed files ourselves. What we want to end up with is something that looks like this, where we can just do toy robot commands.txt and have it read through a list of commands and then tell us where the robot's at and what direction it happens to be facing. Fortunately, in Elixir, we have the wonderful eScript stuff, which you may have used already, hopefully. What we need to do here is we build up a CLI module. It has a main function in it, and this takes the arguments from the command line. We run it through a bunch of different Elixir functions. We have a command interpreter, which turns those commands into things that Elixir can understand, and then a command runner that matches on those Elixir things. I don't have the code here, but I think you can use your imagination. We need to add some configuration to our Mix project. So we need to add that eScript line and an eScript function definition, which will then tell Elixir how to compile our script. If we walk through our little application just in a live fashion, we can see, okay, we're going to place the robot at this particular point on the board. When we ask it to move, it's now going to end up here. If we turn left, it's now going to go like that, or like that. And then if we move it, it's now going to be up against that boundary. But the next thing is that it turns right, and then it moves again, and then we ask it to report. And it now ends up at east 0, 4 north, and it's facing north. So we can validate, you know, we've drawn this up in our little mental map, or maybe even down on some paper. We can validate that the output of our command line is exactly the thing that we wanted it to be. At this point, you're like, well, okay, ship it, no worries. And we've hit 100% on the toy robot, which is great. You send this through to the favorite company you applied for, and they say, you're hired. That's great. Hooray, we succeeded. We start working there immediately. However, this is Elixir, we're cool. Unlike that Ruby language. No, sorry. I'm a Ruby developer, I shouldn't say that. Because in Elixir and because we're cool, we have to use gen servers for everything. It's just how it's done in Elixir. So in order to get past 100%, we actually implement a gen server for our robot. We want to create a game, a MMORPG, or whatever you call it, MMORPG for toy robots. And we start by doing this gen server thing. And that allows us to define a starting position, a table, and we use start link, and we do move, and it's processes, and there's somehow supervisors and maybe even registries in there. Isn't it wonderful? It's wonderful. It's great. Look, we have a supervisor. We can start up things. We use dynamic supervisor, a brand new Elixir feature. We can start up things dynamically underneath it. This is all good. And then our boss says, oh, Internet of Things is taking off. Embedded devices is just destroying the market. We need to get there now. And you're like, oh, good. I've been doing my research and I found out this thing called nerves. And we can take Elixir and we can squish it down into little portable computers. One of these portable computers is a Raspberry Pi, like this. And this one cost me $29.36, plus $6.90 in postage. Thank you, Australia Post. And one of the very first Elixir examples that I chose to run on this was this thing called Blink, I think. The way you get the Elixir onto the Raspberry Pi is you run a command called mix firmware burn, and it goes into that little red chip on the side there. See that little SD card? That's where the Elixir goes. It goes there. And what this does is it makes this little light back here. I don't have a video of it, so I've made one. I made it like a little GIF instead. I showed it to my wife. I said, this is Elixir, look. And she was not impressed. I was impressed because it was blinking. There's a light that's blinking, and I made it do that by running a command that somebody else, code that somebody else wrote. I thought, okay, well, what can I do for this next? And I was like, okay, well, I want to get like an LED board, you know, a multicolor LED thing. That'd be really exciting. Okay, I'm going to drop another $30 odd on this, plus $8 postage. Thank you, Australia Post. Now, this little project is rounded up to about $74 total, which is, I'm sure, something that Invarsion spend on lunch every day. So I tried getting this working when it finally arrived, and I tweeted out, you know, I plugged it all together, put it all together, and it just wasn't working. And they're like, I read the README, and it doesn't lead to the lights turning on, and I'm a software developer, not a hardware developer. How do I even debug this? And the people who sell this particular LED board says, have you soldered it on? This was embarrassing because I used to help my dad solder electronics together all the damn time for his electronic projects, and I really should have known better. So what I ended up doing was going to Bunnings. I got myself a soldering iron kit, and I did an amazing soldering job. In fact, right up top here, that's like melted LED light you can see up there from my amazing soldering job. It was fantastic, but this tiny little thing has cost me $94, and I still haven't got all the Elixir code on it yet. So then let's get back to our narrative just to, you know, we've done the embedded devices thing, but what we haven't done is the Internet of Things thing, right? We've got it, the Elixir, let's say we've got the Elixir on the embedded device, but we haven't connected it to the Internet of Things. The way we do that is we just write some Elixir code. We use plug cowboy. We have a router in there somehow. It's very applicable, cowboy, Internet of Things. It's just, the two things go together. And we make it available that we can now curl to it, and we can ask the robot to move around. That's pretty cool. If we can squish Elixir down onto our little device and we can ask it to move, we then publish it off to the grand internet and we make it publicly accessible. And a boss says, you know, that's not secure. You know, what you need is your username and password. So we add one because that's what makes it secure. And then we end up shipping millions and millions of these units. This reminds me of one extra thing is that the S in IoT is for security. And anyway, we get to 200% of the toy robot. So we have now this thing that is running an embedded HTTP server on an LED board, and we can drive lights and that sort of thing. Our boss then comes back to us and says, you know what would be cool is if this thing did JavaScript. You're like, say no more. I'm going to write this thing that does this JavaScript stuff. And, you know, I'm not going to talk in theory anymore. I'm actually going to show you a real life demo. If I go to this one and go, I just need to clicky a few times. Sorry, folks. All right, now we're better. All right, so we've got this thing, right? So we've got this JavaScript code here, and we've got this little, here it is. This is the thing I built. So there's the Raspberry Pi on the bottom. Remember, that was $30, and this thing was $30 extra, and the soldering iron was $20 extra. This is all it does. All right, so we go up and arrows, and we can move it around on the toy robot. That's a little demo. There you go. Now that's a little bit impressive, but you know, it's still not quite perfect. You know, we're not at 300% yet. We're only 250%. And we get a request from our customer. God knows why they chose to write in Comic Sans, but you know, some people can't be helped. And they say, make it voice activated. I want to be able to move my robot around with my voice. And you're like, oh yeah, that would be cool. I can spend my company's money on this because we're a Series A startup and we've been, you know, given tens of millions of dollars and we can have money to burn. So you think, okay, what smart devices are on the market right now? Google Home, yes, I know that's great, but it's $143 and I can't approve purchases over $100 from my boss. So that's off the, can't do that. So yeah, I think, you know, what else can I do? You know, well, we're a Series A startup, so we're going to cowboy the shit out of this, and we're going to look at a JavaScript feature called speech recognition, which is new to WebKit browsers. And if you look at the can I use stats, you realize, well, only really Chrome and latest Edge have support for it. But it doesn't matter because most of the world uses Chrome anyway. That green line at the top, that's Chrome, and the kind of the brown smear at the bottom, that's everyone else. All right. So speech recognition in JavaScript is pretty cool. What we can do with it is, you saw before I can move the arrows around, right? Yeah, I can do that. Still works, yeah. But what I can do as well, quiet please, move. You see that? Move twice. Move twice. Move twice. There you go. All right, one more time. This is a feature that I've built into my toddler, actually. Seriously, this is, here you go, ready? Ready? Go to your room. So with the power of JavaScript, with the power of Elixir, we can make Internet of Things embedded devices with Elixir, and we get to 300%ing the toy robot. The end. And by the way, you get an invitation to the Internet of Things conference because you're now a dynamic thought leader. Come keynote at our conference. That's the 300% of the toy robot as far as I can do it. Thank you. What questions did you have? Oh, there's a thing. There's some things. Oh. I don't know how to work this, but you pull something out and there's switches. I should make it stop listening to you all.
Is this working now?
Yeah.
You the question?
Hello. Have you thought about attaching a Raspberry Pi to like a RC control, like a car?
Yes, I
and
have.
actually move, like do the toy robot on an actual car?
Yes, I thought there's this little robot called Sphero, and I was going to get one of those and hook it up to a JavaScript API, but I thought it'd be too expensive. But it'd be cool if I could put Elixir on that, because they have a little like ball, and what you can do with your phone is if you tilt it forwards, the ball rolls forwards, left, and so on. But yeah, I'd love to do that with Elixir. That would be a cool project. But so far, I spent $90 so far. I'm pretty much capped out and suspended. Anyone else? Kasha?
So have you documented this anywhere?
No.
No?
I'm gonna make the code open source tonight, so it will be documented there.
What about Toy Robot itself?
The toy robot, yes, I have. Let's skip through this. Oh, by the way, I had this slide as well. Don't get featured on these articles. I have documented it in a book called the Elixir Toy Robot book, which I've been writing. And if you use the coupon code EM for Elixir Melbourne, you can get it for $5. It teaches you everything up to about 150% of what I showed today. The Raspberry Pi stuff is a little too advanced to fit into a beginner's book. So, yeah, it's cool. Thanks, everyone.